Welcome to The Explainer. Today, we're tackling something absolutely fascinating, bridging the massive gap between centuries-old legal logic and modern computational grammar. If you've ever stared at a few lines of code and felt completely disconnected from the dense contracts you know inside out, you are in exactly the right place.
So here's the million-dollar question. Why is it that brilliant legal minds, people who can parse hundreds of pages of mind-bending, layered reasoning and spot a microscopic loophole from a mile away, suddenly hit a brick wall when they look at basic computer code? I mean, it causes real cognitive friction, right? But here's the secret. It is absolutely not a lack of brain power. No way. The core truth here? It's not the logic. It's the grammar. The barrier holding legal professionals back isn't a lack of logical capability at all. Honestly, if you're drafting complex clauses and subclauses, you're practically already doing nested logic. The real issue is that code uses an entirely new grammatical syntax. It's a strict set of structural rules that, frankly, law school never trained you to read. To crack this syntax, we have to totally shift our mindset. We need to move away from that static paper drafting mentality and adopt a dynamic calculus mindset. Think about how we describe fulfilling a contractual obligation. In the legal world, we call that a performance, right? Well, in software, the exact equivalent is a runtime. It's the active execution of instructions. When you start viewing code as the living, breathing runtime of a contract rather than just dead words on a page, the whole computational mindset really starts to click. Think about it like this. A lawyer writing code isn't like an author writing a novel. It's way more like a musical composer writing a symphony. You're designing the entire system beforehand. You're mapping out the verses, the conditions, and the looping choruses. And then you step back, you hit play, and you watch the automated stage performance execute flawlessly from start to finish. You're building the machinery before the runtime ever actually begins. Now, to build that machinery, we have to do something crucial: decouple the logic from the material itself. We have passive data, think text strings, numbers, and true or false booleans, and we separate that passive data completely from the active instructions, which are the machinery. Moving from, say, a static spreadsheet to an active running script, what we call the active canvas, means really understanding how these active instructions dynamically manipulate all that passive data. But whoa, here's where we hit a massive speed bump. What is the ultimate linguistic trap for the legal mind when looking at this active canvas? There's this one specific grammatical hurdle that trips up almost every single legal professional the first time they try to read code. It causes instant cognitive dissonance. Why? Because a symbol you've known your entire life suddenly flips its meaning entirely. Okay, here's the trap. In traditional legal reasoning, and honestly just in standard English, a single equal sign is a statement of truth. It means this equals that. But in code, oh, it's totally different. A single equal sign is an active instruction. It assigns a value. If you actually want to check for equality, like asking the computer, hey, are these two things the exact same? You literally have to use a double equal sign. This one grammatical distinction is the absolute foundation of programmatic syntax. So why is that single equal sign so incredibly hard for us to process? It all boils down to our deeply ingrained English prose left-to-right reading bias. As lawyers, you are intensely trained to read left to right, absorbing facts and arguments exactly as they unfold linearly on the page. But that deeply ingrained habit makes a simple line of programmatic variable assignment look like utter nonsense. To read code accurately, we actually have to completely rewire our brains and our eyes to read in reverse. Let's slow down for a second here because this is absolutely crucial. We're going to trace this exact movement because this is exactly how you train a legal mind to overcome that bias and actually read code. Step 1, start your eyes on the far right. That is where the passive data or the value lives. Step 2, follow the active instruction, that single equal sign moving backwards towards the left. Step 3, store that result in the variable weighting on the far left. You are literally taking the data on the right and stuffing it into the container on the left, right to left. Once you master this specific reverse eye movement, I promise you, the syntax of code stops looking like a foreign language. And here's the best part. Mastering that right to left syntax, that is the master key that unlocks the advanced modular structures of automated law. Because once you can read variables correctly, you can start building true and false Boolean logic gates, which act as the binary foundation for all digital decisions. You can translate those ambiguous legal subclauses into strict if-else conditions, literally telling the computer exactly what to do if a certain scenario occurs. You can automate all those tedious, recurring tasks using for loops, making a single instruction repeat hundreds of times in a split second. And, most excitingly, you unlock contract chaining. Let's zoom in on that last one for a second, because it's a total game changer. Contract chaining is essentially a modular software dependency. Imagine your legal agreements acting exactly like dependent software modules. If a prerequisite contract, let's say a payment or an indemnity clause, breaks, the entire downstream permission chain immediately breaks right along with it. This isn't just a paper breach you argue over later, it is the automated programmatic enforcement of legal dependencies happening live right at runtime. Now, this brilliant modularity actually connects way back to classic computer science design principles from the 1980s. A huge lesson from history we can borrow so we don't have to reinvent the wheel is the Unix philosophy. The whole idea was to write small, simple programs that do exactly one thing well and then have them communicate via universal text streams. Fast forward to today, and this modular text stream approach, using something like JSON, which is just a super universal way to format text that both humans and computers can easily read, is exactly what is future-proofing our legal tools and setting the perfect stage for AI integrations. So all of these concepts beautifully merge together into what are known as Ricardian contracts. Invented by Ian Gregg, a Ricardian contract elegantly combines conditional legalese right alongside a programming language. It's an agreement that is entirely machine-readable for that automated runtime, but also perfectly text-readable for human lawyers. And by using specific computer science pointer mechanics, which are basically digital signposts linking modular clauses together across a network, it allows for a totally seamless, permissionless chain of title that links entire legal frameworks together. Which brings us to this really powerful metaphor for the macro evolution of the legal profession itself. We're moving through three very distinct stages. First, direct law. That's the horse and buggy, traditional analog lawyering. Then, mechanized law. That's the car, our current era of legal engineering operating at hyperspeed but still requiring active drivers and new regulatory guardrails. And finally, automated law, the self-driving Waymos of the future. So the question this leaves us with is pretty profound. As this automation accelerates, will you walk the engineering path, actually creating these systems, or the modernized lawyering path, where reading coding syntax in reverse becomes as natural as writing a brief? The choice is entirely yours. Thanks for joining me on This Explainer.